Now, today we're going to learn section 15.3, finding cube roots. Okay, there is a really simple way to do pretty much this entire lesson with a calculator. Bad news. We're not going to do it the really easy way, because if the calculator does all the thinking for us, we're not really learning much, are we? Okay, so, you know, we kind of have to just grit down and you know, figure it out. But there is a very, I would not call it necessarily simple, but we're going to use that upside down division again. And we're going to use it in cases where we don't know what the cubed root might be. Here's the good news. Once you find the cubed root of a number, you can actually memorize that, okay? So on your quiz and your test, I'm not looking for you to show me the upside down division every single time, okay? So once you know it, you can just write the answer. But if you don't know it, I'm going to teach you the tools that you need to be able to find it. Okay? All right. All right, so some important information. All right, this is supposed to say 15. That's a typo. In section 15.1, I think it says it in your notes, you learned that squaring a number and finding the square root undo each other. So a very similar concept is going to happen in 15.3. Today, you learned that cubing a number and finding the cubed root undo each other also. Okay, those are inverse operations. So that's really important. All right, so in example one, we're going to find the cubed root. Again, we are going to play, we'll call it the ignorance card, that we have no idea, and maybe you don't, okay? But again, once we find the cubed root once, we can memorize that and just know that's the cubed root every time. So let's pretend that we don't know what number could be multiplied by itself 3 times to equal 8, right? Because to raise to the third power, that's something times itself 3 times. If we don't know, we can do the upside down division. Okay, what's the smallest prime number that would go into 8? 2. How many times? 4. And then 2 goes into 4. 2 times. And then that's a group of 3 2s. So to find the cubed root, guys, to find the cubed root, it has to be a group of 3 for cube. So then for each group, I would write it one time. Well, since I only have one group of 2s, I know the cubed root is 2. Okay, so for each group, I would write it one time. If I have more than one group, I would then multiply those numbers together. All right? So again, this is my fallback method if I don't know what the cubed root is. Okay? All right, let's do 27, the next one. All right? So the cubed root of 27, what's the smallest prime number that goes into 27? 3. How many times? 9. And then what goes into 9?
3.
How many times?
3.
Okay, so the great thing is now, again, how many 3s do I have? 3. So I can circle that as one group. And since I only have one group of 3s, 3 is the cubed root. But why did I make it negative?
Because 27.
Because 27 was negative. So don't factor in the negative when you're doing the upside down division, but don't forget it in your answer. If it was negative in the original problem, it needs to be negative in your answer. Okay, what do you notice about number 3?
It's a fraction.
It's a fraction. Remember what I taught you about square roots. On square roots, you can split it. It's the same for cubed roots. This is important because what if the numerator is a perfect cube, but the denominator is not? Okay? So we can take the cube root of both numbers. Well, one, guys, what number can be multiplied by itself 3 times to be 1? It's just 1, okay? So we don't need to do the upside down division for that one. But now let's do 64. And again, we don't know what it is yet. Even if you do know, let's act like we don't. What is the smallest prime number that goes into 64? Smallest prime. Okay, so it can only be divisible by 1 and the number itself. So 2, 32 times. 2, 16 times. 2 goes into 16 how many times? 2 goes into 8 how many times? 2 goes into 4 twice. So now I need to follow my rule again. For every group of 3, I can circle it. So I have one group of 2s. Do I have another group of 2s? Yes. Okay, so I write each one time and I multiply them together. What's 2 times 2?
4.
So 4 is the cubed root of 64. Okay, 4 is the cubed root of 64. And if you test that, you can test it in your calculator. What's 4 times 4 times 4? Just to check it.
You mean 1/4? Oh, 64, yeah.
64. We're just checking the denominator.
Oh.
Okay, all right. So again, the upside down division is my fallback for when I don't know what the cubed root is. All right, so let's move on to example 2. So in example 2, now we have expressions, meaning we have operations involving square roots, whether it's addition or multiplication or whatever it is, okay? So here we have 2 times the cubed root of negative 216. Well, we don't know what the cubed root of negative 216 is yet. Or we just need to act like we don't, okay? So let's act as if nobody in here knows what it is. Let's do the upside down division. Okay, what's the smallest prime number that goes into 216? 2. Okay, 2 goes into 216 108 times. You can use your calculators for that division. Okay, you can. You just can't use it with the cube root button. Okay, so 2 goes into 108 how many times? 54. 2 goes into 54 how many times? 27. Okay, so now there's no more 2's. Does 3 go into 27?
Yes.
9 times. Does 3 go into 9?
Yes.
Yep. Okay, so now I'm looking for my groups of 3. Okay, do I have a group of 2's?
Yes.
Yes. Do I have a group of 3's? Yes. What did I say I do with each group? Okay, write it 1 time. Okay, so 1, 2, and 1, 3. Multiply it together. This is the cubed root. But what do I need to remember?
Negative.
The negative. Okay, so negative 6. What am I going to do with the negative 6 now?
Oh, yeah, multiply by 2.
Multiply it by 2, and my answer is negative 12. Again, guys, because we have no calculator, if you get to this question on a quiz and you know that the cubed root of 216 is 6, you do not have to show the upside down division. You don't have to show it. If you want to, A, double check it, or B, if you don't know it, now you have a method you can use to figure it out. You with me? You understand? Okay. Look at the next one. The cubed root of 125 cubed.
125.
How did you do the math that fast? Because it undoes itself. They are inverse operations. The cubed root and cubing a number cancel out, and all I have left is the original number itself. The original number itself. That's it. Okay? So if you understand that shortcut, no upside down division, none of that work. You just understand they cancel, and your answer is 125. So much easier. Are you going to catch it?
No.
Are you going to remember?
No.
Okay? The answer should be, I'm sure going to try. Okay? Or yes. Okay? All right, next example. We're still in example 2. We're just doing a little more practice. I want you to do these 2 on your own. I'm going to kind of check on you guys and see how you're doing with this, see if anybody has any questions.
Whoa. Oh.
All right, did you guys remember what the cubed root of 8 was?
Yes.
It is 2, okay? So Good news, if you remembered that, you didn't have to do the upside down division. 18 minus 4 times 2. So what do I do next? Multiply, not subtract. 18 minus 8 is 10. Okay, if you subtracted first, you did not get the right answer. Okay, so make sure you follow order of operations. Anybody get the last answer?
Yes.
Good, awesome. Sarah, what did you get? Did you have to do a lot of math? No? What did you catch there? Inverse operations, guys. The cubed root and cubing, those operations cancel each other out. And now I just add them together, actually subtract and take. Negative 21. All right, anybody get negative 21? Just get that answer right, negative 21. Okay, good job. Yay. All right, example 3 is solving equations with cube roots. All right, and this concept has come up several times already in this lesson. We need to do the inverse operation of cubing a number to get the exponent to cancel out. So if I need that exponent of 3 to cancel out, can anybody take a wild guess? What would I need to do?
You cube the other one.
You cube root it. Cube root it, okay?
Yeah.
So I take the cubed root. Guys, this sign is not the cubed root. Okay, you say, well, Ms. Kinder, I know what you meant. Well, I might know what you meant, but I'm still not a mind reader. You have to show me what makes this a cubed root. What do you need to write?
3.
The little 3. Okay, now the x is by itself. That's great. What is the cubed root of 216?
6.
Do you remember? Do you remember? Didn't we do this one? We did this one. It's 6. Okay, now with square roots, it would be positive and negative 6. But with cubed roots, it's one or the other. Because negative 6 3 times would be negative 16. 216. Okay? So my answer is either positive or negative. It's never both with cubed root. All right, does that make sense? With square root, a negative times a negative is a positive, so it can be both. All right, look at the next one. I need to get that n by itself. What would I do? What would be step 1, Gabe?
I think it's divide negative 1/4 on both sides.
Well, it's already a fraction, which is technically division. What's the opposite of division? Multiplication. Multiply it by what?
4 over.
The reciprocal. No. By negative 4 over 1 to get those fractions to cancel. Now, whatever I do to one side, I have to do to the other side. Okay, so I have n to the third equals negative 8. All right, go ahead and finish that problem. Okay, so cubed root, both sides. What'd you get? Negative 2. All right, I want you to do the next one completely on your own. Okay? Now remember, we do the cubed root last, so the first thing I need to do is get rid of that 3 that's connected to b. Okay, so do that first, and then you're going to find one. Remember, you can't take cube root with your calculator. This is one that we have not done yet. Okay? So you're going to have to do some upside down division, more than likely. Okay, what do I do first, guys?
Divide by 3.
Divide both sides by 3. Okay, now b to the third power equals 343. I don't know what goes into 343 yet. I haven't had this one yet. So we're going to test it. Remember, we can only divide by a prime number. 2 doesn't go into it. Add my digits together. 3 plus 4 plus 3 is 10, which is not divisible by 3. So that one doesn't work. 5 doesn't work. So my next guess is 7. Does 7 go into 343?
Yes.
How many times? 49. 7 goes into 49 7 times. I love it when that happens because now I have a group of 3 7s, which means that 7 is the cubed root.
Oh, you were looking for cube?
Uh-oh, what did I forget here?
3.
Yes, the little 3 on the cube root sign. Okay, again, so well, Miss Kinder, you knew what I meant. I even have all my upside down division. I know what it meant, but you still have to write the little 3. Okay, so now look at the last one. What's different about the last equation?
It's in a different form.
Okay, it's kind of flipped, isn't it? Like the m comes second. Guys, you can rewrite this as long as you keep all the signs the same and you keep them on the same side. You could say negative 1/5 m to the third plus 8 equals 33. Okay, so subtract 8 from both sides first. I have negative 1/5 m to the third equals 25. Now, how do I get negative 1/5 to cancel? Times it by negative 5. Okay, so what's 25 times negative 5? What is it? Negative 125. Okay, so now I need to do the cubed root, okay, of negative 125. What did you get? Maybe you did the upside down division. What did you get for cubed root? Negative 5. M equals negative 5. Remember, my answer will either be positive or negative. It can't be both. If you don't know the cubed root, do upside down division. Only divide by prime numbers. Okay? All right, hold on. I know by the tone of my voice it sounds like we're done. I want to review with you real quick. You remember how we learned the perfect squares all the way up through 15? Yes. Okay, let's recite those together just real quick. We start with 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. In all 15 of those numbers, remember, only 15 numbers from 1 to 225 have an even square root, where I can take the square root and it's a whole number. Guess what? We can do the same thing with cube roots. And this is going to save us work. If you have the cube root memorized, you don't have to do the upside down division. So let's talk cube roots. 1 is a perfect cube. 1 times 1 times 1. What's my next perfect cube? 8. 2 times 2 times 2 is 8. What's my next one? 27, because 3 times 3 times 3. You with me? So the next one, 4 times 4 times 4, 64. What about my 5s? 125. What about my 6s?
216.
216, we did that one. What about my 7s? 343. We just did that one in the last slide. Okay, so guys, this right here, if you can have these 7 memorized, that eliminates a lot of the work too. They're the most common 7. Am I saying you're never going to have one bigger? No, you might have to do the upside down division. But these are some of the more common ones. So just right below it, which number is the cube root? The 1, 2, 3, 4, 5, 6, and 7. I may ask you a question like a true-false question. I might say true or false, 200, or you can take an even cube root of 200. Would that be true or false? Is 200 one of these numbers? No. So if you know them, you would just say false, no big deal. If you don't, you might find yourself off to the side trying to do upside down division to figure out the answer. Okay? So having these memorized could be really beneficial. And now we're done. Okay, so that's the only other thing I wanted to cover with you guys. And that's everything you need to know for 15.3.